All right, and we're live. So we don't have anything new for today. I will be going through one of the forms with you guys, just jumping through and doing some of the shell methods at the end. Again, the quiz is still the same format that we've been doing. You'll have disk method, shell method, and some volume by cross sections. I do want to go over some final examination review materials really quick that are available to you guys. We have 4 weeks as of right now before your final exam. So the rest of the class is going to be kind of going back and prepping for that. Your final exam is cumulative, so that means it covers everything that we've covered all year, all the way from probability at the beginning of the year up through our disk method, shell method that we've covered over the past 2 weeks. So on course sites, if you scroll down to final examination materials, so that's the very last entry. Once you hit that, you'll load up with this page. I've got the diagnostic tests that are there, which are 10 question quizzes on every major topic. These ones are in alphabetical order. But they're up to 10 questions. You take them immediately afterwards. It will spit out not just the answers, but the step-by-step solutions for the long form problems. So that's a good way to start. I would start by taking all the diagnostic tests. Once you've taken the diagnostic tests, it'll give you an idea of what you need to study. After you've taken the diagnostic tests, whatever you didn't score well in, you can go back into your final examination review and scroll down to the study guide. Once you download that, it's a fairly large zip file. Which when you open it up, it'll look like this. So your first file within that document is an overview of what the exam is all about. I am going to be making some slight changes since we'll be including our 3-dimensional volume problems, which aren't listed here for last year's overview. But it gives you an idea for what topics are going to be on the exam. For everything other than integration is going to have a little bit extra. It'll have one more section for 3-dimensional volume. Okay, and then for every topic that's on the exam, you also have a document that can help you prepare. So this is probabilities. Just list everything that is there for probability and then gives you a quick overview of everything you need to know. And I've done that for every topic that's on the test. So I would go in there and let's say you took your quiz and you didn't do so well on vectors. So I might jump into the intro to vectors and projectile motion sections and spend 15 minutes or so just reading through, trying to remember everything that I forgot on vectors, looking through some of the example problems. And then once I've done that, back on course sites, you've got previous year's exams. So I've uploaded the 2017 exam. I'll be uploading the 2018 exam and the 2019 exam from previous years up to here as well. The version that just says that year, that exam, includes the answer keys. If you don't want the answers, hit the version that says no answers from the same year, and you can use that as a way to test yourself. Any questions on how you can study?
Are these files too big to be uploaded in the group chat or, yeah?
I believe the exams will be. The study guide and the exams are about 20 megabytes apiece. You can try it though. Okay, I can't upload to that. So the study guide's already uploaded. The final exams are not yet though. Okay. I've also got under midterm review materials the midterm keys from several previous years. So for quarter 1 and 2 topics, that's a good way to study as well. If you want to go back even further than that, if you click on resources and then previous year's finals and answers, that'll go back beyond 2017. The class didn't include as many topics before 2017. The final exams are a little bit easier and not as comprehensive, but there's still additional problems that you can try for probability and that sort of thing. Again, with answers or without. Okay, so I'm going to jump back into your quiz. Yes. Nikita? I may have lost him. If you remember your question, come on back. Okay, so these are your quizzes. You've got your form ID numbers, which are the same as last time. So I'm going to jump down. I have an extra form here that we'll be looking at. Just from one of these, new shell method, because I think that was the most missed. Let's do this one. This one's the hardest. Okay, so before I get started with this, Abby, since you're the first in the order, what about this tells you that we need to use shell method to solve it?
The x-axis.
Okay, so as long as our axis that we are revolving around is a vertical line, so that means a line that's going up and down, then we'll need to use shell method as long as we don't want to change our variables. So I know this is shell method.
Sorry.
So we know this is shell method. I'm just going to draw really quick.
Yeah.
So I'm going to pick a point somewhere. Oh, that's a little big. Okay, I've just lost my Skype people, so I'm going to recall. Okay, hello Nikita. Alright. So we said we know this is a shell method problem because we've got a vertical line that we're revolving around, so I'm going to set this up. So for shell method, I'm going to draw a box between our I'm going to draw a box in our area from the top to the bottom, so something like this. That box has an infinitely small change in x, but also has a height. And I'm going to use that box to spin around our axis of rotation. And create a three-dimensional shell. Okay, so this is my infinitely small change in width that we had here in yellow. That we are using to form our circumference. So to get that circumference, we'll need our radius, which is our distance to the center, which is the axis of rotation. So we'll need a radius as well, which will be this distance here. Let me spin it around. Okay. So next on the order, I've got Andrew.
Yes.
Andrew, how do I get the height?
It should be -4. No, I mean 2x minus x squared, because 2x is the upper function and x squared is the lower function.
Okay, so 2x minus x squared is my distance between these. So our height is 2x minus x squared. Our depth is our infinitely small change in x. And the last thing I need is a radius. What would the radius be?
It should be x plus 4.
Perfect. Our radius is our rightmost x value minus our leftmost x value, which for us is our x value right now, minus the axis of rotation, which is -4. So that's x minus -4, or x plus 4. Any questions on our height, radius, or depth? Okay, and we're going to plug that into our volume equation. So we could say our volume is 2 pi r, that's our circumference, times our height times our width, would make this a three-dimensional volume. Again, we get that by taking our cylindrical shape with a hole in it. And if I was going to cut that, we would end up with a box that would have an infinitely small dx, a distance around, so a width of this box of my circumference, and a height. So that's 2 pi RH. I'm going to call this dx w for width, which gives us our formula for the integral. And then we're going from a starting x value to an ending x value, which is from a to b. Okay, next on the order is Eric. So I'm going to plug all of this in and have you simplify. What is my a and what is my b?
Can you repeat?
What is the start point and what is the end point? I want to know what the bounds of this integral should be.
The A and B.
Yes.
0 and 2.
0 and 2, perfect. We can see it on the graph right now, but if I couldn't see it on the graph, we could set these two functions equal to each other. So 2x equals x squared. So I can subtract 0 equals x squared minus 2x, factor out an x, 0 equals x times x minus 2, which would be true if x is 0 or x equals 2 for intersects. So let me zoom in here. Let's go ahead and multiply this out, and then once we've got it simplified, I'll pass to the next person. So Eric, again, can you multiply this out for me?
Okay. 2 plus 2.
Okay, I've got 2x squared, if you want to do it that way.
Minus x cubed minus 2x squared plus 8.
Okay. So I think you combined like terms there, but that's all right. I'm gonna go ahead and throw that as a separate step just so we can show everybody else what you're doing. So this is negative x cubed minus 2x squared plus 8x in terms of x. Okay, next on the order is Kyle. Kyle, what happens when I integrate?
So it's negative x to the power of 4 over 4 minus 2x cubed over 3 plus 8x squared over 2. So 4x squared.
Okay, awesome. From 0 to 2. Um, go ahead and do your simplifying you just did. Oops. Okay, and then Nikita, we need upper bound minus lower bound.
Okay, so that's gonna be 2 pi negative 16 over 4, or just negative 4,
Okay.
minus 16 over 3, plus 16, and that's it.
Okay, and then when you plug in 0, all of that is 0. I would still have to distribute the 2 pi though, so that's minus 2 pi times 0, which is 0. Okay, what's my common denominator?
12.
Okay, I could use 12. If I simplify this to 4, I could use 3. I might do that actually. So this would be 2 pi. This would be negative 4 plus 16. So I've got negative 16 thirds plus 12. So if I get a common denominator now, I'll use 3. How can I add these together?
It's just gonna be negative 16 over 3 plus just a second. well, 20, 12 times 3 is it, times 36 over 3. Plus 36 over
Okay, what is 36 minus 16?
3. 20 over 3.
Okay, so I've got 2 pi times 20 over 3. So what's our final answer?
40 pi over 3.
Perfect. Which would be the volume of the shape that results if we spun this two-dimensional area in blue about our axis here in black. We'd end up with a crazy hollow shape by stacking a bunch of these two-dimensional cylinders on top of each other. That hollow shape, though, would have a volume of 40 pi thirds. Any questions on what we did for shell method?
No.
Okay. So I'm going to end it there for this class. If you guys want to look back over disk method or volume by cross sections when you're taking your quiz, over on the YouTube channel or on the cowtransfer.com links that I've been sending to the WeChat every day, you've got all the previous videos. So under Calculov, playlists, pre-calculus. We've got all the videos that we've had so far since we started our quarantine. Down at the bottom, you've got disk method, um, washer method with trig functions and others, shell method, and then mixed review. Go back further for volume by cross sections. Okay, thank you guys so much for coming. I will see you next class period where we'll start going back through the final exam review, starting with probability.
Bye.
Goodbye.
Thank you.
Thank you.
Bye.
Bye.
Thank you.